also injects this new thing where somebody can take over the vehicles. And we've already demonstrated it can be done without autonomy. Imagine when you have no control of the vehicle and you're just going to watch the accident happen. It's been taken over. We've demonstrated it can be done. And so understand that there's actually guidance. The Department of Transportation put out Safety 2.0. It's called the, it's basically guidance for autonomous vehicles. And they've got 10 recommended guidelines. They're 100% voluntary. How's that working for us, right? Now, one of them, and this is where I came in, I said, that's very good guidance. But one thing that you should legislate, you should require that data logging and data recording is a part of that. That's one of the recommendations you should require. Because people are saying, oh, but we're learning. We're going to learn about autonomy and do that. I'm sorry, if you don't do data recording, is all you've got is an accident occurred, you look at bent metal. Is that going to help you understand? Did the software fail? Did somebody from the outside come in and send a spurious command? You don't know, unless you've got data recording. Now, of course, some of the staffers came up to me afterwards and said, well, you know, what you're asking for, you know, that's a lot of computing power. That could take up a lot of space. And I said, how much computing power do you think you got in this? I mean, think about it. Is that too heavy on the car? I said, this is more than enough to do data recording for a vehicle. But you have to want to do it. Now, I will tell you the auto manufacturers are actually doing some data recording, but it's theirs. It's not, they don't even share with insurance companies. That's going to start changing also. Because you only have to have more and more accidents in this, more and more people dying. The insurance industry is going to say, hold on, this isn't working so well. I mean, you have seatbelts today, not because the consumers wanted it, it's insurance companies wanted it. So again, we've got a lot of examples where people have actually died. And I actually asked the question while I was at a NIST conference on IoT. I said, so how many people have to die before we're actually going to do something about this? Nobody likes that question. But you know what? That's the only thing that's going to change the behavior. More people have to die. Isn't that unfortunate? But it's kind of a reality. So what we're seeing today, because all of you have been in this business for a while, you know we focus on quality for a long time. We saw a shift with quality and security. By the way, if you actually look at the ISO standard, the 25000 series, security is actually a subset of quality. But how many of your companies treat security and quality different? Meaning you actually say, these guys are responsible for quality assurance, safety and security are done by other people. The standard says these are one and the same. They actually treat
share reports.
The reports are what?
They don't even share reports.
They don't share reports even. Yeah. But again, they'll use that to argue whose responsibility is it to fix it. But today, because of all the financial liability associated with it, we're seeing a focus on quality, security, safety, and privacy. Privacy, as you know, with GDPR in California, everybody's now starting to pay attention to data protection. You know, within the Department of Defense, they're rolling out the new cybersecurity maturity model certification. Well, it's 100. Well, most of it's based on NIST 800-171, which is data protection. Now, I think it's a misnomer to call it cybersecurity just because you're focused on data protection. It's a key element of it, but it's certainly not all of cybersecurity. But today, software-controlled devices is what's got everybody's attention. Everybody's concerned about it, but people don't necessarily know what to do about it, other than say, it's those bad guys. Now, one of the organizations I like is the Industrial Internet Consortium. This is a lot of the large companies, you've got something like over 500 companies now, coming together to focus on IoT. And so they came out in February this year, the IoT Security Maturity Model. They have a practitioner's guide. And why I like this, because it provides a nice little framework. Their security maturity focused in 3 key areas: governance, enablement, and hardening. And that's further broken out. And what I really want to focus on is one part of each of those. Supply chain dependencies is part of governance. And supply chain dependencies management in particular. Asset protection is part of the enablement. And vulnerability and patch management as part of hardening. If you think about today, while we hear about all the bad guys, all the malicious actors, you get all kinds of reports, but ultimately you can't control the threat. But what you can do is understand your attack surface, and that's where vulnerability and patch management become a key part of it. I'll talk about that more. But this becomes a very key part to where we're moving in the future here. And so enters the whole concept of supply chain risk management for software. This is a way of enabling our enterprise to control the risks that are attributable to exploitable software. Because if you're not doing this, you're just falling victim to all the things that are happening out there. And think about your supply chain. Whenever you need something, you turn to somebody to do that. Now, you have to understand, at the enterprise level, we do risk management. But we focus on regulatory compliance, a changing threat environment. We have a business case. We may know we've got fundamentally faulty gear or something, but we can't change out everything. We make a business case for it. We got to do it. But in all cases, this user organization turns to a purchasing organization. You need to go buy me this fix. And the purchasing organization turns to a supplier. And both the purchasing organization and the supplier focus on risk management as well. But it's at the project level. And you can all say this in your sleep. Program or project risk management, all about cost, schedule, and performance. Cost, schedule, and performance. You say it all the time. And you think, well, we'll get our security based on performance. Really? Have you ever read your contracts? It talks about functional performance. Do you really put anything in there about security? I don't think so. So unless you're really talking about the enterprise needs, you're not really getting that. So what you're doing is you're allowing your purchasing organization to set your priorities. Purchasing organizations are prioritized and rewarded based on acquiring really cool stuff for a really low price and fast. And they turn to suppliers who also have the same incentive, because the supplier is only going to do what the purchasing organization asks for. If they do more, like make it secure, well, that would be gold plating. And so they don't even do that, right? But what a lot of people think, well, I'm dealing with that supplier, but what you're really doing is dealing with that supplier's supply chain. Some cases they're going to reuse components. They may turn to a sister development. They may do in-house development, which, by the way, in-house development may incur, it could be local staff, but in a lot of these cases, we've got broad development houses where we're talking there's foreign involvement. And if any of you are in a high assurance environment, you may actually have to badge people in and stuff. You might find that there are people involved in your supply chain who you wouldn't let into your building, but you'll just go ahead and accept their software and plug it into your enterprise. That's pretty cool. Think about it. Yes, question.
So doesn't that happen predominantly now? Because it's my understanding that software development has evolved to the point where you're always pulling in already built code from somewhere.
Yes.
Typically a repository. In fact,
I'm going to go into details about that.
Okay.
You're absolutely correct. My point is, you don't even know where your software came from. Yet, you think that's okay. Yes?
And there are not that many suppliers. People don't know that, but there are not that many suppliers, and the different devices get made, but they're coming from the same source.
Yes. And Don uses this as the diamond supply. It's like, yes, it goes out like this, but all of a sudden you look at all these suppliers, and it whittles down, they've got very few. When the tsunami hit Japan, there was a quick realization of that, because it took out a lot of these small little companies. They found out all the auto manufacturers relied on them. It just,
There you go.
it was just, but it was like this. It came down to very few. You're absolutely correct. But in some cases, we are choosing just to acquire outsource. But the point is, in all of this, you have people making risk decisions on your behalf. They're making risk decisions that are based really on their needs, their risk, and their risk is about delivering something fast that satisfies what the purchasing organization asks for. But who determines fitness for use, or what is technically acceptable? It's what you put on contract. Who owns the residual risk from tainted and counterfeit products?
That's the dark
You
world.
do.
I was going to say, things are in the dark world being sold to
Yeah,
reputable companies, but they haven't checked it out.
right. That's exactly
We
right.
know this from doing the pieces.
This is what we refer to as poor cyber hygiene.
Yes.
They're just not even looking. So tainted products, when I talk about that, they're corrupted with malware or exploitable weaknesses and vulnerabilities. So we get both counterfeit as well as tainted products in the system here. Now, this is an IoT supply chain challenge because we're seeing an increasing dependence on globally sourced devices, varying levels of development outsourcing controls, and when I say varying levels, it's, in some cases, no outsourcing controls, it's just like, there's a lack of transparency in the process chain of custody. Some of that, you referred to that as provenance. I'll also address pedigree, or provenance means you don't have a clue who's been touching your devices. And this varying levels of acquisition due diligence, some cases it's none. And so we do see in the federal government with Department of Defense, DHS, there's some stepping up of what we're doing with due diligence, trying to understand that. We're seeing residual risk from tainted components with malware, exploitable weaknesses, and vulnerabilities. I'm going to come in here and talk about these. So I'm going to use CWEs and CVEs. How many of you at least heard of CVEs? Okay, you're an ISSA, so yes. Have you heard of CWEs? The common weakness emulation. Okay, some hands go. We'll talk about what the relationship is and why you should care about both. Well, today we're seeing a growing sophistication among adversaries because the internet today allows them to probe, penetrate, and attack you remotely, and the supply chain attacks can exploit the products and the processes along the way. In fact, I will tell you, because as an enterprise, most organizations have gotten much better at the guns, gates, and guards, putting up the firewalls, putting up DMZs. We're getting much better at protecting that. So what they're going after is the supply chain. Why? Because they know you're not checking. It's like, that's the true Trojan horse. Just open up the gates and let them in. And so software in the supply chain is often the vector of attack. And the evidence comes in from many different reports, depending on who you like to read. Carnegie Mellon put out a report, 84% of breaches originate at the application level. SAP, 84% of all cyber attacks happen at the application level. Gartner, over 70% of security breaches happen at the application. NIST, over report, 92% of vulnerabilities are in the application. It's like, do I need to keep going on? It's in the software. That's where we're doing that. But here's the reality. A lot of people say, no, it's phishing attacks, spear phishing attacks. That's our problem. Employees are clicking on links. They shouldn't be doing it. It's our employees' fault. Well, let's look at the anatomy of a spear phishing attack. Yes, there is a social lure, referring to something recent in the news or something that happened in your company, and there's an exploit link in that email. And there's a fingerprinting script that it's deployed with that. But what it's doing, it's looking for known vulnerabilities or exploitable weaknesses in your system that your IT department failed to fix. That provides the path. If I get CDs out here, maybe a Flash exploit or Windows privilege, I'm not pointing out the company. The point is, these are the path. And then the payload's delivered. And it's because the employee clicked on that. Well, you know what? If you blank this out, if you actually patch that, you can click on it all day long, and the payload cannot be delivered. But let's blame our employees. As opposed to saying, Mr. ID department, why did you not patch that in time? So, think about it. I'm not saying you should not have your anti-spear phishing campaigns going on in October, National Cybersecurity Awareness Month. Definitely do that. Because we have to go to employees because our IT departments haven't secured our infrastructure. It's just kind of a reality, so we got to make it, everybody's got a responsibility. The ultimate thing is, should my mother know that she shouldn't click on something? It's like, think about that. And I like what the Industrial Internet Consortium has really talked about in terms of what's important in this space. They focus on trustworthiness of these industrial IoT devices. And what they refer to trustworthiness is any device where you can trust it if you have a degree of confidence that the system performs as expected in respect to all key system characteristics. And that's where we look at safety, privacy, resilience, security, reliability, in the face of environmental disruptions, human errors, system faults, and attacks. Now, when you start looking at this, when you decompose this, focusing on safety and resilience, or safety and security, is actually pretty easy. Because I can demonstrate that a system that is not secure in today's environment is not reliable. If it's not reliable, it is therefore not safe. I mention this because we have a lot of safety regulations. It's one of the most, regulatory regimes for safety have been there for a long time. We don't have as much in the area of security, but my contention is you don't need new regulations. You just have to put on your cybersecurity goggles and demonstrate it's not cybersecure, it's therefore not safe. You do that link. Because people who only do a hazard analysis of looking at external things, you're not doing it. So all these, I will tell you, the link with privacy and security, I contend, you cannot have privacy without security. However, there are privacy people said, you know, when you want what you want for security, we got a problem with from a privacy perspective. Balancing this out is a challenge. But if you know going in, you're going to support both of those, you actually can design systems better. So again, I like what the Industrial Internet Consortium has done, is to focus on trustworthiness. Well, why is it that we have to do that? You understand, you've been in here, just if you didn't already know this coming in, most enterprises realize, well, software is buggy, it's flawed. And so our enterprise has this squishy part here that we've got to protect. And so we've done a lot of extraordinary measures. We've put up firewalls, we put up DMZs, we put up intrusion detection systems, intrusion prevention systems. We pray a lot that nobody's going to come in and target us. What I found interesting when I was talking about this several years ago, I had somebody in the back of the audience, he was actually mad. He said, you know, ever since they made us install that intrusion detection system, we are being attacked far more frequently now. Yeah, that's the response he got. And then he just sat down like, oh, I said it out loud. But look, the reality is you can start learning more about your attackers, the threats that are out there. But you can't stop them. You know, the idea that, well, I'm going to block them, I'm going to disable this, I'm going to close that port, I'm going to do that. You know, what I...
Functionality.
Yeah, well, you know, what happens, we realize that most cyber assets, their real utility is being connected. And if all you do all day long, block, 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 after a while, it's a brick. And then we find people, because they forgot, why would we open up the ports, we start, it's just like you go right back to it. So you can't control the threats, but what you can control is your attack surfaces, the attack vectors. And that's in the form of the software that's being attacked. That is the exploit target. If you're familiar with the STIX architecture, and STIX is actually, I should have actually put up some slides here about that. We started, the granddaddy of them all is CVEs. And I was the sponsor for that. I took over sponsorship of it when I was in DHS when it ran out of money. There was no money for it. And so they said, well, CVE dies. I said, no, this is too important to the community. I'll take over. They said, you're going to use your budget to help fund it? I said, I don't have enough to do all that. So, but for over 10 years, I was a sponsor for CVE, and we never got budget for it. It was 10-cut management. Kept going around, but we kept it funded. But we then started to say, we need to understand the attack surfaces. You know, what is actually creating all those CVEs, and that's why we created CWEs. Let me come to that later to talk about this. But this, all of this, these enumerations grew into what we have as STIX and TAXII, what we report out. So I should have spent time talking about that. I'll come back to talking about that later. Because we find that everybody's got security in play. We do something, we try to secure, but we're still not being successful. What they're doing is they're going after the soft underbelly of the enterprise. And I'm using terms here, and I know you've at least heard of these terms. SQL injection attacks or cross-site scripting attacks. I know you've at least heard of those. Some of you may actually know what those are, but some of you don't. But the point is understanding what we did is we started codifying these to help people understand it, because that's where we also introduced CWE. We care about the attacks because they're coming after these weaknesses in software, and we've actually codified those as CWEs. Why do we care about CWEs? Because these CWEs are the exploit targets, are the vectors for future zero-day attacks. That's what these are. And once they're a zero-day attack, we now codify them, and they become a CVE. It's no longer zero-day because we put it out there publicly to do that. And I always find it quite entertaining. You know, you'll hear almost on a weekly basis somebody else oh, we've been victimized, another zero-day attack, I've been victimized. Actually, you should be very ashamed. It's like you're basically publicly admitting that somebody else was more committed to finding your CWEs, because these are yours, they're in your system, 100% discoverable. Somebody else is more committed to finding them and exploiting them. So don't let your bosses go out and say, we've been victimized. It's like, you shouldn't be proud of that statement, because these are yours. 2/3 of the CWEs are code level. I say that because that means we can run tools and find them. And so you can get that out. The CVEs are obviously 100% reportable because they're known vulnerabilities. So you've got tools, so we do that. And you have to understand, this is a time when anybody should be using something. Meaning, because there's over 300 products and services that discover and report out CVEs. Pick one. If your organizations are not going after CVEs, these known vulnerabilities, it's like, really shame on you. It's just like, I wouldn't want you as part of my supply chain, because it's like, you're just easy picking. And so like I said, just pick, yes, we have tools, Coverity does this very well in that space, but pick one. Just start discovering it. And this, typically people think of that in terms of the operational environment. No, you look for CVEs in the development environment. We'll talk about why. Why is it that we're finding known vulnerabilities in new software that's coming out? And that goes back to what we talked about earlier about the composition, about bringing in stuff. So what is the relationship between CVEs and CWEs? Relationship between weaknesses and vulnerabilities. People like, now maybe I'm overly, what's the right word for it, other than say that I care about this because a lot of people always want to call everything vulnerabilities. But the broader category is really weaknesses. And the existence of an exploit designed to take advantage of weaknesses and achieve a negative technical impact is what makes a weakness a vulnerability. So that means all vulnerabilities are a weakness, but not all weaknesses are vulnerabilities. Even though people like to use the generic term and just say everything's a vulnerability. Why is that important? Is because different tools look for different things. If you're only looking for CVEs, you're missing all the root causes. Because this says we're only looking for things that other people have already found. It's like I'm going around looking for broken glass. But wouldn't you like to know what the source was that caused that? The reason we're seeing this exponential growth, we now have over 170,000 publicly reported known vulnerabilities, CVEs. We still have fewer than 1,200 CWEs, the root causes of them. But the malware is taking care of the screen. But in the middle, you've got the 0 days. Like I said, 0 days are, they take advantage of the CWE, and it's reported out as a zero day, and then it becomes a CVE. So you just go through that. So, by the way, these today are now international standards. We sponsored this through the Department of Homeland Security when I was there, of doing this, and so ITUT, which is the standards body for the United Nations, therefore these are recognized by over 109 nations around the globe. It's translated in 6 different languages. It's part of the Cyber Information Exchange, or the CyBEX series. CVEs, ITUT X 1520. CWE, ITUT X 1524. KPEC is on there. KPECs are basically the exploits that take advantage of CWEs that now become CVEs. There's a relationship. And you can say, I don't understand these. My message to you is, you don't have to. Tools basically have the domain knowledge, and they'll report that out for you. And I'm actually kind of come to that, back to the end of this. Interesting feature we have here, clicking in and out. So CVEs and CWEs today can be used to assess software maturity. If you're bringing in software from somebody else, or even your own development teams, you should be running tools that look for these. So questions are commercial and open source applications being used as part of the system, the development environment, the test environment, to detect CVEs and CWEs? Or to patch for known CVEs. It's amazing how much new software comes out with CVEs that are over 4 years old. New software, and that the developer chose not to even patch that. Or any component libraries incorporated in the system that have CVEs. That's the big challenge. We identified that earlier, talking about open source software, people pulling from libraries, bringing stuff down. Many of them still have a lot of known CVEs that they want to patch. Pen testing uses CVEs. We have scoring systems that go with these. CVE has the Common Vulnerability Scoring System, CWSS, the scoring system for CWEs. I'll talk about how you actually use this to prioritize what to look for. But it's just a way of sharing information about exposures of software that are in your supply chain. And it's amazing to me how many organizations have their approved products list, or they're whitelisted, or they're assessed and cleared products. And when I asked them, I said, so in order to get on that list, you tested them for known vulnerabilities and weaknesses? And they look at me, what are you talking about? I said, how did it get on your approved products list if you didn't look for exploitable weaknesses and vulnerabilities, or even malware? Do you realize that whitelisted projects, and they come in, they whitelist the malware? Isn't that cool? That they're not even checking for it. And so in your company, you might want to ask, who's doing the whitelisting? Who's doing the approving of these products? Are you testing for that? You're looking like a maze. Surely that's not happening. I hate to tell you, which government agencies already know for a fact that they don't even look for that. So I got to believe at the enterprise level, it's certainly in there as well. It's important actually to use things like these scoring systems. I'll use just the CWE as an example. Why do you care? We actually came out, we worked with SANS Institute, we've worked with a lot of security experts, and we came out with the CWE Top 25. And that's a new list that's just come out this year, CWE Top 25. That's important, but some people say, okay, we'll just use that, we'll look for those. Actually, my recommendation, and the reason you want to use a scoring system, is based on the technology you're deploying and the environment in which you will be deploying it in, you would actually have a different score for different CWEs. So you come up with your own top end list. It could be top 20, top 40, whatever that is. You say, these are the most important weaknesses for the technology we have. Let's go, because once you know that, then you said, now we want to make sure that our test regime will actually address these, either through code reviews, static analysis tools, or maybe we do pen testing, so that we cover all the weaknesses that we care about. That would be important why you want to be able to do that. So there's different lists that can help you get started, because a lot of organizations I find, oh, don't make me do that. Let me just pick one of these others. So we've got OWASP Top 10. Everybody here has heard of the OWASP Top 10. Do you realize the OWASP Top 10 is the same? No, it's changed over time, but it's still, 9 of them are looking for CWEs. But A9, on the OWASP Top 10, A9 says using components with known vulnerabilities. That means the over 170,000 known vulnerabilities, that's A9 on the OWASP Top 10. So you got to be looking for CVEs. The others are CWEs. OWASP actually has another list that I want to talk to you a little bit. It's called the Application Security Verification Standard. 4.0 is now out. I'm going to actually talk to you a little bit about that because you probably never heard about it. So we have the top 10, and that just changed. I'm going to talk to you about the CIS, the Consortium for IT Software Quality. We just recently changed the name. I'm on the governing board for this. It's the Consortium for Information and Software Quality. We have structural quality technical debt measures, 100% based on CWEs. We actually developed new CWEs as a result of doing this exercise, working with industry to do that. So there's a way of getting started. Do one of these. The ideal thing is you're actually developing a personalized, tailored list for yourself, but maybe your company, well, they'll understand some other industry grouping and go after that. So the Application Security Verification Standard, what I like about this, it's proscriptive. It's telling you these are the controls that you have in place. And they range from architecture and design, with threat modeling, authentication verification, session management, down to malware verification, business logic, configuration verification. These are things that are telling you what to do. But I can run static analysis tools to go in because 100% of these are looking for CWEs. I can run static analysis tools and say, nope, you've got this CWE in place. By the way, this number right here is a quality CWE. We started off with CWE being all about security. The newer ones, everything numbered 1,000, well, it's actually 9,000 now. But these are, we're starting to include weaknesses that are purely quality weaknesses. The point is, you can run static code analyzers and say, you have this CWE present. That means you have not implemented that control. So it's a way, your best report is running this and you get nothing because you don't have those weaknesses. Because so long as you have these weaknesses in place, you cannot implement a control. And that's important to understand. So what do we do with CISC? We look at 4 areas: security, reliability, performance efficiency, and maintainability. So we have weaknesses, 100% based on CWEs, and the examples here, SQL injection, cross-site scripting, buffer, you're familiar with these. And so these are 100% based on CWEs. We basically had an international team of experts selected the weaknesses to include in the CISC measures based on severity of their impact on operational problems or cost of ownership. And you're going to see how this traces to technical debt, because we basically said these are so egregious that they should not remain in your software. And so that's what I said. These have to be remediated. It's just a matter of when do they get remediated, not if they should be. So it's structural quality measures. They've been extended to embedded systems and software. And they're all out there now. We actually, like I said, we introduced a new group of quality measures. MITRE incorporated that, so you now have more CWEs there. And we have a traceability between the CISC structural quality measures, and they're aligned with ISO 25023. This is on software quality. And specifically, if you look at software product quality in the 25,000 series, you look at reliability, performance efficiency, security, and maintainability. Those are the ones that CISC has chosen to actually automate the collection of that. Because if you go to the ISO standard, they don't automate that. They just talk about it. So it does conform to the quality characteristics and definitions. It's aligned with it. But we actually give you a way of automating your compliance checking. And so if any of you are supporting audit agencies or anything, this is a way of checking software that's coming out. And you've got a recognized international standard that talks about software product quality. We can automate it and give you that information. And that's where technical debt comes in. If you think about the metaphor for technical debt, is that you have the future cost of repairing must-fix defects. Like I said, it's not a matter of if, it's a matter of when. They remain in the code release. It's a component cost of ownership. And so you are basically, if you've got these structural quality problems, it becomes technical debt if your development team passes it on to your enterprise or to your customers. And every one of you know, the longer down that supply chain, the more you shift that to the right, it's more expensive to fix it and to address it. That's why we've been advocating shifting left. The more that you want to do, you want the developers to actually be able to fix that. And so technical debt means continuing IT costs attributable to the violations causing technical debt. It's higher maintenance costs, greater